Okay, in this lesson, we're going to practice getting 4 ordered pairs and saying, okay, what shape is it? Okay, and so I think the first question is, okay, if you know it has 4 ordered pairs, it will be a quadrilateral, okay, right? And so I would get out this sheet that I gave you a couple days ago, and I would say, okay, if it's quadrilateral with 4 sides, the first question is, are both pairs of opposite sides parallel? And the easiest way to check that would be to see if the diagonals bisect each other. Okay, find the midpoint of each diagonal and see if they coincide. Because if they do, the midpoint of one diagonal will be equal to the midpoint of the other diagonal, and therefore the diagonals will bisect each other. Okay, so their midpoints of each diagonal should coincide. So that's the first thing you're going to do. And if so, you will have a parallelogram. Okay. If you have a parallelogram, you're like, okay, is that as far as I can go? If the answer to your next questions is no, well, then you're going to stop and say, hey, I have a parallelogram. If, however, the diagonals don't bisect each other, I would suggest you go and see, are at least 2 sides parallel? And if so, then you have a trapezoid. And if 2 of the sides are parallel, then you should check to see, is it an isosceles trapezoid, where you can check to see, are the non-parallel sides congruent or just are the diagonals congruent? Either way will tell you if you have an isosceles trapezoid. Okay, so check to see if you have a parallelogram. The next step will be, do you have a rhombus? Okay, and how you check for a rhombus is, you can pick one of those next 3 things on the left. Okay, so if you have a rhombus, the 3 things above it will be true. And the easiest way to check that would be, are the diagonals perpendicular to each other? Do they meet at a right angle? So check the slopes of the diagonals and see, are they opposite reciprocals? And if so, you have a rhombus. So you can stop there. Well, okay, you should check to see one more thing. Okay, the last thing you should check to see is, do you have a rectangle? Okay, so if you have a parallelogram, check to see if there's a rectangle. And so how you do that would be, you, getting the color for us, let's get a really dark blue. Let's check to see, are the diagonals congruent to each other? Okay, if the diagonals are congruent, I guess that's great. If the diagonals are congruent, then you know you have a rectangle. Oh, there's the purple, okay? And so if it's yes to a parallelogram, yes to a rhombus, and yes to a rectangle, then actually you have a square, okay? If it's no to a rhombus, but yes to a rectangle, you stop at rectangle, okay? So if it's yes to both of those, all 3 things, then you have a square. Okay, if it's no to rhombus and yes to parallelogram and rectangle, then you stop at rectangle. So go as far as you can, and then you can report that to be your final shape. And I think the easiest, the least mathematically difficult is to focus on the diagonals. Okay, yes, you can always pick another feature and be like, hey, I want to just show that opposite sides are parallel. Well, then of course you'll have a parallelogram. I want to show that one pair of consecutive sides are congruent. Well, then you can show you have a rhombus. I want to show that I have a right angle and show that the 2 consecutive sides meet at a right angle. Awesome. You can do that instead. But the speediest way is to show that you have, check for each of those shapes consistently down the chart is going to be the ones that I've highlighted. Okay, so you can actually, unless I tell you specifically what you have to do, you do have some choices. So on these notes, it does say go through these 3 steps. And so I think the big thing is just to practice, like, can you actually answer these questions? Okay, do you have a parallelogram? Okay, that's the first question. Check the midpoints and see if they coincide. And so find the midpoint of each diagonal. So the diagonal of the shape would be A to C. Again, they're not on a graph, but the shape goes A, B, C, D around it. So AC would be the first diagonal. So if you find the midpoint of A to C, so you would do x plus x divided by 2 and y plus y divided by 2. So you do 1 plus 7 or 8 over 2. And then you would do 2 plus 0 divided by 2. And that would be 4, 1. Okay. And that would be the midpoint from A to C. And let's find the midpoint from B to D, the other diagonal. And so to find that midpoint, you're going to do x plus x. So it'd be 5 plus, that number is a 3, so it'd be 8 divided by 2. And then the y plus y would be 4 plus negative 2, so that's 2 over 2. So that would be 4, 1. Guess what? They coincide, so therefore you have a parallelogram, okay? So it would be a parallelogram so far. Okay, so we were like, check. Okay, there is a parallelogram. The next question is find the slope of each diagonal to say, hey, is there a rhombus as well? Okay, so let's check it out. So let's find the slope of each. So let's do from A to C. Let's find the slope. And let's do from B to D and also find the slope. Okay, so from A to C, you're going to do y minus y. So 0 minus 2 over 7 minus 1. So it'd be negative 2, 6, or negative 1/3. Okay, so we have to say, are the diagonals perpendicular? Okay, opposite reciprocals. Because if they meet at a right angle, you have a rhombus. Okay, so let's do from B to D. So let's go 4 minus a negative 2 over x minus x is going to be 5 minus 3. So it's going to be 6 over 2 or 3. So if one of the slopes is 3 and one is negative 1/3, they are perpendicular. So yes, rhombus. Okay, and the next question is it going to be a rectangle? Are the diagonals congruent to each other? So we have to find the length from AC, find that diagonal's length, and go from B to D and find that diagonal's length and see, do you also indeed have a rectangle? So let's find the length from A to C. So the distance formula says subtract the two x's. So it's going to be 1 minus 7 squared and 2 minus 0 squared. So that's 6 squared or 36. 2 minus 0 is 2 squared, which is 4. So that's going to be square root of 40. So that's going to be the length of one diagonal. And we could reduce it, it'd be 2 root of 10. But at this point, we're like, just what is it? So from B to D, it looks like I colored over that in B. So let's erase that. And from B to D, we're going to do x minus x. So we're going to go 5 minus 3 squared, and then 4 minus a negative 2. So 4 plus 2 squared. So that's 2 squared, which is 4. 6 squared, which is 36. We get the square root of 40. So it's yes to a rectangle. So if you say yes to all three, then guess what the shape is? It's a square. Look back at your chart. You can tell if it's yes to all three, it's going to be a square. Okay, good job. Let's look at the next shape. So again, we're just practicing mathematically. Can you do these appropriately? So let's find the midpoint of each diagonal. So from A to C, let's find the midpoint to look to see, is it a parallelogram? Because if the diagonals are bisecting each other, where the midpoints coincide, well, then you have a parallelogram. So A to C and B to D. Let's find those midpoints. So you do x plus x divided by 2. So A to C would be negative 5 plus 3 divided by 2, and 8 plus 1 divided by 2. So it would be negative 2 over 2, which is negative 1, and then 9 over 2, which is 4.5. Okay, let's look from B to D. The midpoint from B to D would be negative 4 plus 2. That's negative 2 over 2. And then 3 plus 6, which is 9, divided by 2. So it would be negative 2 over 2, which is negative 1. And then 4.5. Hey, look, they're the same. So it's yes to a parallelogram. Okay. So the first one's yes, we have a parallelogram. We showed that the midpoints coincide. Second thing is, are the diagonals perpendicular? Do you have a rhombus? So let's do the slope from A to C. M equals, and then we'll do the slope from B to D and see what the slope is. Okay, so if the diagonals intersect each other at a right angle, you have a rhombus. Okay, so let's do it. So the slope of A to C is 1 minus 8 over 3 plus 5, and that's negative 7 over 8. Okay, and then from B to D is 6 minus 3 over 2 plus 4. That is going to be 3 over 6. That's a half. Well, those are not true. So you do not have a rhombus. Not a rhombus. Okay. Okay, so not a rhombus. That says rhombus. So it's not a rhombus because the slopes don't intersect at a right angle. They intersect, but not at a right angle. Okay. Now let's find the length of the diagonal and see, do we indeed have oh dear, do we indeed have a rectangle? Okay, if the diagonals are congruent, you have a rectangle, and if you have a parallelogram. So let's check for a rectangle. So let's find the length from A to C, and let's find the length from B to D. Okay, the length from A to C is x minus x, negative 5 minus 3 squared, and 8 minus 1 squared. Let me see if that's right. Yeah. Okay, so negative 5 minus 3, and then 8 minus 1 squared. So that'd be negative 8 squared, which is 64, 7 squared, which is 49. Let's see if we can add here. Okay, it's 113. I was just checking my key. I'm like, did I get the same answer before? Okay, the answer is yeah, I did. So 113. So the length from B to D, I bet you it's not going to be the same, but let's check it out. So from B to D, okay, so let's do 2 minus a negative 4 squared. Subtract the x's. Actually, you can do either order. It doesn't matter for this. For slope, it matters. For distance, you just minus the x's and square it. And mind your signs. So this is going to be 36. And then 3 minus 6 or 6 minus 3. It doesn't really matter as long as you mind your signs. So it's 9. Yeah, that's going to be 45. So the square root of 45 is not equal to that. So it's not rectangle. So the only one we said yes to was a parallelogram. So guess what? It's a parallelogram. Okay, there we go. Let's check. We've got 2 more to practice. Okay, so let me move over to the other one. I'm not sure how well this is going to work for us. Oh my. Okay. A little bit awkward, but okay. So the first one says, okay, let's check to see, is this quadrilateral a parallelogram? Yes or no? So let's do the midpoint of each diagonal to see, do the diagonals bisect each other? So let's find the midpoint from A to C, and then also from B to D. Okay, always pick the 2 points across from each other to find the midpoint. Okay, non-sequential points. Okay, vertices. So from A to C, that midpoint is going to be negative 3 plus 5 over 2, and then also 2 plus 0 over 2. So you got 2 over 2, which is 1, and then 2 over 2, which is 1. So it's 1, 1. And then let's check the next one from B to D. Let's do x plus x. So it'd be 5 plus 1 over 2. And then negative 4 plus 3 over 2. So 6 over 2 is 3. Negative 1/2. Okay, this is no. So no. So what do? Okay, it's not a parallelogram, so there's really no point in doing the next 2 things, except this is what I would suggest that we do, okay? I would suggest to see, are any 2 points, okay, are any 2 lines parallel to each other? So let's find the slope from A to D, okay, because it might be a parallelogram. I mean, not a parallelogram, it might be a trapezoid, they call it, sorry. So let's find the slope from A to D, okay? So the slope from A to D, the slope is equal to what? Negative 4 minus 2 over 5 minus a negative 3. So that's negative 6 over 8. So that's negative 3/4, okay? And let's look at also the slope from B to C, okay? And see, are those 2 sides parallel? So let's do 0 minus 3 over 5 minus 1. So it's negative 3 over 4. Oh, that does. So these 2 sides are parallel to each other, okay? So I betcha the other 2 aren't, okay? So let's check to see, are the other 2 not, okay? So let's do the slope from A to B. So it's 3 minus 2 over 1 plus 3. So that's 1/4, okay? And let's check down here, 0 plus 4 over 5 minus 5. So that's undefined. Okay, so those 2 sides are for sure not parallel. Okay, so we're going to have a trapezoid of some sorts. We just have to check to see, is it an isosceles trapezoid? Okay, so we've got one pair of sides that are parallel, so it's going to be a trapezoid. But then my question is it an isosceles trapezoid? So you can either check to see, are the non-parallel sides congruent, or are the diagonals congruent to each other? Because remember, in isosceles trapezoid, the diagonals would be congruent. So let's find the length of each diagonal. And so let's do from A to C, find that length, and from B to D to see, yeah, I see one pair of sides that are parallel, and that means we have a trapezoid. But is it also an isosceles trapezoid? So the length from A to C, using the distance formula, is going to be -3 minus 5. That's squared. And then 2 minus 0 squared, that's 8 squared is 64. And then 2 squared is 4, that's the square root of 68. And then from B to D, let's check it out. X minus x, so it'd be 5 minus 1 squared, and then -4 minus 3 squared. That's 4 squared or 16, 7 squared, which is 49, 9 and 6. 4, 5, 6, 65 and 68. No, these are not going to be the same. So the truth is that that it's not isosceles trapezoid, so it's just a trapezoid. Okay, so that's a good thing to figure out. Okay, so if you don't get a parallelogram, you should back yourself up and see, hey, instead of finding the slopes of the diagonals, then look to see, do you have actually a trapezoid? Is one pair of sides parallel and not the other pair? Okay, and then you should check to see the diagonals to see, hey, is it isosceles trapezoid? Okay, you're doing a great job. And then the last one, let's check to see, do we have a parallelogram? So let's find the midpoint of each diagonal. So let's go from A to C and then from B to D. So from A to C, you're going to do, midpoint would be x plus x. So it'd be -4 plus 4, which is 0 over 2. And then -1 plus 3, which is 2 over 2. So it'd be 0 and 1. And then from B to D, the midpoint of that would be 1 plus -1 is 0 over 2. And then you add the two i's, 3 plus -1 is 2 over 2, which is 1. So 0, 1. So it's a parallelogram. Okay, that's cool. Now let's check to see, are the diagonals perpendicular that you'd have a rhombus? So find the slope from A to C and from B to D. Okay, from A to C, the slope would be, let's see, 3 plus 1, which is 4, over 4 minus a -4, which would be 8. That's 1/2. And then from B to D, y minus y is going to be 3 minus a -1 or plus 1 over -1 minus 1, which is -2. So it'd be 4 over -2 or -2. Hey, look at this. They are perpendicular, so you have a rhombus. Okay, and then the next step is, hey, is it a rectangle? Okay, so let's check out, is it a rectangle? And so we have to find the length from A to C and from B to D and see if we have a rhombus. I put a segment over that. We don't need that. We are finding the length from it, so we don't put a mark over it. So let's do it. Okay, so the length from A to C is x minus x, so -4 minus 4 squared, and then -1 minus 3 squared. So that's 8 squared, which is 64, -4 squared, which is going to be 16. Carry the 1, 6, 7, 80. So the square root of 80, yes, I would break down, but we don't really care. And then B to D, because we're just saying, are they equal? Okay, not what is a simplified length of that diagonal, okay? So from B to D, you're going to do x minus x, so -1 minus 1 squared, which is 2 squared, which is 4, or -2 squared, either way. And then 3 plus 1 squared, so that's 4 squared, which is 16, and the square root of 20. Yeah, not so much the same thing, is it? Okay, so the diagonals are not congruent, so it's not going to be a rectangle. So the furthest we can go is it's a rhombus. All right, so those are the steps. Thank you so much, and I hope you have a great day.